Hi, welcome back to my channel. In the previous video, I have discussed Ohm's law with you, and today, we are going to dive into practical applications of this fundamental law. Further, we will discuss what are nodes, branches, and loops. Let's get started. Let's start with a basic example, a simple circuit with a resistor. For example, we have a 9 volts battery connected with a 3 kilo ohm resistor. We are interested to find the DC current flowing through the resistor. According to Ohm's law, V is equal to I into R. Rearranging the equation, I will be equal to V over R. Plugging all the values will give the result of I is equal to 3 mA. Let's simulate the circuit in Tinkercad software, which is freely available online tool. First, we will place a 9-volt battery by just drag and drop. Next, we will place a resistor and connect it with the battery terminals. As we want to measure the current which we have already calculated, so we will place an ampere meter in series with the rest of the circuit. Setting the value of resistor to 3 kilo ohm and setting multimeter to ampere meter. Now, simulate the circuit and you can see that ampere meter reading is 3 mA, which is exactly the matched with our calculations.
Next, let's light up an LED. LEDs are commonly used in various electronic devices, but they need a specific current to operate safely. The LEDs comes in different colors and their operating voltage depends on the color of LED. As you can see in the table, that red LED has minimum operating voltages while blue and white LEDs requires higher operating voltages. The standard current for LED is 20 mA, but higher brightness LEDs require more current to glow properly. Let's suppose we have 9-volt battery connected with a resistor and LED. Assume that the LED is red, which required 2 volt and 20 mA of current. We are interested to find the value of resistor, which will ensure to pass 20 mA of current through LED safely. Again, using Ohm's law, V is equal to I into R, and by rearranging, I will be equal to V over R. In this circuit, there is 9 volt at one terminal of resistor while 2 volt on the other end of resistor, which create potential difference of 7 volts. These voltages will be dropped across the resistor, hence, protecting the LED from damage. So, after calculations, the value of R will be 350 ohms, which we can use with 9-volt battery to protect red LED, and it will also ensure proper light intensity of LED. Let's simulate the LED circuit in Tinkercad to verify our calculations. We have placed a 9-volt battery, a resistor, red LED, and an ampere meter to measure how much current is passing through the LED. Further, we have placed a voltmeter across the resistor to measure the voltage drops across it. According to our calculations, the ampere meter should display approximately 20 mA of current, while the voltmeter should display approximately 7 volts. Let's simulate the circuit, and you can see that ampere meter shows 19.7 mA, which is close to our calculation of 20 mA. Similarity, the voltmeter shows 6.9 volts, which is closer to our calculations of 7 volts. Now, let's have a brief look of the terms of network topology. The first term is the branch. Any two-terminal device like resistor, voltage source are called as branch. The next term is node, which is the junction or point of connection of two or more than two branches. For example, these three resistors have one common point which will be called as node. Loop is any closed path. For example, we have a circuit consists of multiple branches and nodes, so, we start from a node, will passes through different nodes and returns to the starting node. This will form a loop. There is a simple formula to calculate the number of branches, loops, and node. The formula is B is equal to L plus N minus 1, where B for branch, L for loop, and N for nodes. For example, we have a circuit, and we want to know the number of branches, nodes, and loops. For branches, we will just count the elements of the circuit. This circuit contains 4 elements, means it has 4 branches. For nodes, we count the junctions of circuit. This circuit contains 3 junctions, hence, it contains 3 nodes. With the information of nodes and branches, we can calculate the loops using the formula. Plugging all the values into formula, we will get 2 loops which can be matched with overview of circuit.